Now we've got a frequency distribution here. Okay, let's say that our blood pressure is only read to within 5 points. So we have 120, 125, and so on. That's the best we can read the scale. Or we round off to the nearest number. In any case, in making a number of observations, we say that we have 3 readings of 120, 6 of 125, 10 of 130, 16 of 135, and so forth. Now, how would we find the mean of all these readings? Well, we could list all the readings. Okay, we could list 120 3 times. So we could say, okay, let's see. To get the mean, we're going to have to add 120 3 times. And then we're going to add 125 6 times. Okay, now this is going to get a little tedious, especially if these numbers are real big. How can we use common sense to figure out a quicker way of doing this? What do you think? We're trying to add up we're trying to add up 6 of these and 10 of these and 16 of these and so forth. Pause for a minute and think about it. What would you do? Well, it seems obvious now. You should have paused already and thought about it, but we have 120 times 3 or 360. That's what these are going to add up to. And these 625s are going to add up to 6 times 125, whatever in the world that is. I guess that's 750. Okay? And then if we want the 10 130s, well, 10 times 130 is 1300, right? So if we add up all those numbers, if we're going to add up all those numbers, we can simply think of, okay, we're going to add up 320s, but that's going to add up to 360. And the 125s are going to add up to 750, and 10 130s are going to add up to 1300. And 1635s, what in the world's that? Well, I guess that's going to be 4800 plus 80 is 4880. And 12 times 140, that's going to be 1680, I believe. Wait a minute. 16 times 135 can't possibly be 4880. It's 16 times 13. Somebody's not thinking here, and I guess it's me. Okay, anyhow, let's see. 16 times 130 would be 1600 plus 480 would be 2080. So I think that's probably 2160 there. Okay? Then 145 times 8, that's going to be 1160. This is going to be 900. This is going to be 310. I should have made these numbers easier, because I've probably made a terrible mistake in here someplace. In any case, this is what we get when we take the reading times the frequency. And again, the reason for doing that is pretty simple. Again, 3 120s add up to 360. 6 125s add up to 6 times 125, or 750. Now if we add all these numbers up, and I've really been cruel to myself here, haven't I? Let's just do this quickly. That's 11, 17, 25, 31, 32, 38. Okay, and I'm doing this quickly, and I'm probably going to mess it up. That's 6, 13, 16, 17, 23, 24, 33, and 4 is 38. And that's 3, 4, 5, 6, 8,880. Now what's the average? Now common sense tells us the average is going to be somewhere close to the middle here in the 135 to 140 range most likely. Now how are we going to get that? Well, how many numbers did we actually add up here? You say, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not right. We didn't add up 9 numbers. We added up 3 of these and 6 of these and 10 of these. To get the number of numbers that actually got added, we have to add the frequencies. 3 of these, 6 of these, and 10 of these, and so forth add up to what? 3, 9, 19, 35, 47, 55, 61, 63, 64 readings. Okay? So we have 64 readings. Which total 8880. What's the mean? Well, common sense here, 8880 divided by 64. Whatever that equals. Okay? Now let's see. 64 would go into 9600 150 times, and that's 620 less. So I'd say that's going to be about 141, approximately, with a question mark. But that does seem to fit with the distribution that we've got here. It seems that 141 is a pretty good estimate. So that this method of adding up a frequency distribution should make good sense to you, and it should work. Now we're going to formulate that in a minute.